In this example, we have 8 different kids, 4 of all different ages. 4 of them are given Kings Island tickets. What is the probability that the 4 given the tickets were the youngest 4? Okay, this problem is actually, it gives a lot of students problems, and a lot of them have gotten it wrong. I took this problem from a test I actually had last semester, and I changed it a little bit because I didn't want to use the exact same wording and stuff like that. But this is a problem. This is a problem that a lot of people got wrong, and it's pretty confusing because you can use either combinations or permutations, and well, you have to do it the right way depending on which one you use. And if you don't have a pretty thorough understanding of the two of them, then it's easy to get it messed up because it's confusing as to which one you should use. So like I said, you can use either one as long as you do it right, and I'm going to show you both ways and why. Okay, so first off, I want to do it the combination way. And so you can think about it like this. You have, first off, we'll do you have 8 kids of all different ages. You know the youngest 4 are given tickets. Okay, so essentially you're really choosing 4 of the youngest 4 and giving them tickets. So you can think about that as the number of ways to choose 4 of the youngest kids. And as always, when you're setting up a probability problem, you need to know number of ways to choose 4 youngest, and then number of ways to just choose 4 kids. Okay, so we already know the top of that, and that's C of 4. And the bottom's pretty obvious. How many ways are there to choose 4 kids out of 8? Well, there's C of 8 4 ways. You're choosing 4 from 8. So you know combinations. You know that C of 4 is just going to equal 1, and you know that C of 8 4 is going to look like this. I basically, when I do this, I just multiply this number by, I don't really follow the equation. I do, but I don't. I just multiply this number times however many times the value of this number is. So in this case that's 4, so 8 times 7 times 6 times 5, and you know that 8 minus 4 is going to be 4, so you really would have another 4 times 3 times 2 times 1 over here, and this would continue on. But there's really no point in doing that because you know that that's just going to get eliminated, and it's going to leave you with just r factorial if you're following the equation, which is 4 times 3 times 2 times 1. And this is going to end up being I don't know why I put a comma there, 1680 over 20, or yeah, over 24, and that is going to give you, one second, yeah, that's going to give you 70. So you know that C of 8 4 is equal to 70. So you know that right there is our answer. Number of ways to choose 4 kids is C of 8 4, which is 70, and the number of ways to choose 4 kids from the youngest 4 kids, well, there's only one way to do that. That's 1 over 70. So the probability that the four youngest kids are given tickets is 1 over 70. Okay, now that was the combination way to do it. And I'm going to show you, I'm going to go ahead and show you. Some people just prefer, some people are better with combinations, some people are better with permutations. So we're going to show, I shouldn't have erased that actually because that would stay the same. This right here, you're always going to be wanting to find, well, in this particular problem, the number of ways to choose the 4 youngest, and that's really sloppy, but you know what I mean, and just the number of ways to choose 4, because to have a probability, obviously you have to have it set up like this. So we're going to do this with permutations now, and the problem's kind of tricky because I should have explained this more when I was explaining the combinations, is because in combinations order does not matter, in permutations order does matter, and the wording of the problem is kind of confusing because it makes you want to think that order does matter, because it says they're all different ages, and what is the probability that the 4 given tickets are the youngest 4? So that would kind of make you think that order doesn't matter, but order does matter, but really it doesn't, because we're really focused on just giving tickets to the youngest 4. It really doesn't matter what order we do that in. If we give, say there's a 5, 6, 7, and 8-year-old, and those are and then the other kids, let's say, are 9, 10, 11, and 12, and these 4 get the tickets. Well, it wouldn't be different if we gave the 6-year-old a ticket, and then the 5-year-old a ticket, then the 8-year-old a ticket, then the 7-year-old a ticket. It doesn't matter. They all still got a ticket, and that's what we're focused on. So I think you can see what I mean by that. If this were a permutation, these 2 right here would be 2 different permutations. They'd be 2 different things. But in this case, by the wording of the problem, we're only focused on giving the 4 youngest kids tickets. So if they get the tickets, they get the tickets. It does not matter what order they get them in, as long as the youngest 4 get them. So that's why it kind of gets confusing, and why you might think order matters. All that matters is that the youngest 4 get tickets. It does not matter which order. But again, we can do this like a permutation, as long as you do it the right way. And the way you can do that is by finding the number of ways to give, well, in this case it shouldn't say choose, it should say number of ways to give the 4 youngest kids tickets. And to do that, well, if you're going to use permutations, there's 4 times 3 times 2 times 1, because you're starting out with 4 youngest, and then you give one of them a ticket, and now you have 3 of the youngest. You give another one a ticket, then you have 2 of the youngest kids left, and then you give one a ticket, then you only have 1 youngest kid left to give a ticket. That's the number of ways to give the 4 youngest kids tickets. And then the number of ways, and this again shouldn't say choose because this is permutation, just to give 4 tickets to 4 of the 8 kids. Well, that would be, well, you have 8, you give 1 a ticket, now you have 7 to give 7 kids to give a ticket away to, now you have 6, and then you have 5 left. Okay, so after this you've given away 4 tickets, and that's all you have. So this will equal 24, and this will equal 1680, and basically that will reduce down to 1 over 70, and that is the probability that the 4 youngest kids are given tickets done through permutations. I hope that helped you differentiate between combinations and permutations, and when order doesn't matter. We're going to have a lot more videos on order and when it doesn't matter in combinations and permutations. So if you're still confused, don't worry, you can watch the lectures again, or you can re-watch this practice problem, or you can check out a lot more of the other practice problems we have.